Hi everyone, and welcome to a webinar from one of our NCBC exhibitors, Aerosol. My name is Liz Fisher and I'll be your moderator for today's session. Reminder that we have muted all the lines to minimize the feedback and any background noise to stop the distraction from the presentation. I want to remind everyone of a couple of our features of our webinars. When you logged in, you'll notice you had a control panel. When you first joined, this panel appeared on your right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When it's maximized, you can use this control panel to submit questions or any chats that you need with questions on technical difficulties. When you are submitting a question regarding the presentation, please type them in the question box during the presentation and hit send. If it is regarding a particular slide, please include that slide number so the presenters can refer back to it. With that, I'd like to introduce today's presenters. We have Neil Walsh and John Villani. Neil Walsh is the Senior Vice President and Strategy and Commercial Sales for Aerosol. Prior to this role at Aerosol, Neil was the Vice President at Aerosol Inc. and more than 8 years, and has several years experience with Carrier Corp as well. Neil has extensive knowledge in HVAC arena for both commercial and residential applications, along with his expertise in distribution dealer, sales team management, and development. He has a BS in mechanical engineer from Oregon State University and an MBA from Yale School of Management. John Villani is the Vice President with Grumman Backus Associates in Chicago. For the past 12 years, John has been an engineering consultant providing design, energy, commissioning, retro-commissioning services. His background as an owner, contractor, consultant enhances his perspective as a commissioning engineer, in addition to the experience of working in several of the country's major cities, including New York, Chicago, and Detroit. John earned his undergraduate degree at SUNY Maritime College. John also serves on the International Board of the Building Commissioning Association. So with that, I am going to turn over this presentation to Neil and John.
Thank you very much. Really appreciate the introduction. Today we're going to talk about why duct leakage generates such a powerful savings opportunity. Then John's going to give us an actual example of a project where he was able to generate those savings for his client. Then I'm going to take a few minutes and talk about how this measure works. Now let me explain why duct leakage is such a unique opportunity. As we know, in buildings with excessive duct leakage, increasing the fan flow to compensate for that duct leakage generates 4 very powerful energy wasters. First, it increases infiltration load. Second of all, it increases the amount of money spent on heating and cooling. It increases the operational cost of the fan, and the fan motor generates excessive heat, which creates an additional load in the building. Now let's look at the situation. Do ducts leak? Yes. All the experts agree ducts leak. In a small building, 30% of the air doesn't make it in the occupied space. And over half the buildings, well over half the buildings, that's just air that's wasted directly to the outside. In a larger building, 10 to 20% of the air is short-circuited from the supply back into return. That's a lot, any way you look at it. 10 to 30% efficiency points are wasted because of duct leakage and duct installation. Now let's talk about so what. So what if ducts leak? Well, according to ASHRAE, that's a big so what. They say that system leakage significantly increases energy use. In fact, they go on to say that a VAV system that's leaking uses 20 to 35% more fan energy than a tight system. And that's just the fan energy. And in fact, they go on to say an exhaust system with leakage can increase fan power by over 95%. Now let's now I'm going to take a few minutes and let John explain to you a very specific example of how he applied this opportunity for a client. John?
Thanks, Neil, and thanks, Liz, and welcome everyone. So this is basically kind of a combination of building off of what Neil talked about in energy savings, and really from a commissioning perspective, fixing a problem. So it's really a testimonial to what we did and utilized Aerosol. So quick background and kind of the plot of the story is we were doing a healthcare project. We designed it, and what we were doing was adding the USP 797 pharmacy requirements into an existing building. So existing hospital had a pharmacy, has to comply with these new requirements. So we had to build some new space for the clean compounding and chemo compounding for pharmaceutical drugs in their pharmacy. So something the hospital had to do, they had to comply, they didn't really have a lot of budget, so it was typically done on a tight budget, and as a result they were looking to sort of minimize costs in every way they could. So we ended up looking at existing ductwork that was already in the building. Go ahead, next slide. So what we found is our pharmacy was down in the basement, and there had been a lab down there. And as a matter of fact, there was fiberglass ductwork that was going from the basement where our pharmacy was all the way up to the 4th floor penthouse that was capped and unused. And what you can see here is the actual ductwork. On the left, you see a picture with 2 ducts. One is fire wrapped. That is the actual duct that we ended up using. And then right next to that, there's a white duct with a red X. That was exactly the same thing. That was the left duct. It was a fiberglass duct running down a shaft of 4 stories, and it was in a fire-rated shaft, so we didn't have access to it below. But that is the fiberglass duct construction, and you can see the pictures on the middle and the right. That's actually looking inside the ductwork, what it looked like, what the construction was. And again, that's about 30-year-old fiberglass ductwork. And from our perspective, we were like, okay, hey, it's the right size. We can make this work. Let's utilize that and avoid the cost to do that. So, okay, this is going to help the project. This is a plan view of the basement. And what you see in the red rectangle there is that's the new space that we added to the pharmacy, which is on the bottom of the drawing. And in that red rectangle is the clean compounding room is on the left of the rectangle, in the middle is the ante-room, and on the right side is the chemo compounding room. And not that it's too important to understand that, just trying to give you a reference point. Not a huge project, not a huge space, just added into the existing pharmacy. And we're going to be talking about that exhaust ductwork that runs from left to right, and you can see the arrow. You can see that running across all 3 rooms, and then it's actually traveling to the left of the drawing. And just make a note right about where that arrow is, the yellow arrow. There's a sink and a bathroom right there. That is kind of pointing to the bathroom right there in the plan. So you'll get a picture of that later on and understand. So just trying to give you a little background of this new pharmacy space. So what we did was we had that existing fiberglass duct. It was running from the basement all the way up through that 4th floor. Above the 4th floor is the roof. This is a picture of the roof. We sized and spec'd out a brand new fan. It's got a 3 horsepower motor, new fan, and that's new ductwork. So that's just kind of 2 different views of the fan up there on the roof. So pretty straightforward. It's going to be a high plume discharge fan because it's coming from the pharmacy area. So pretty straightforward, simple. Sized it all up, figured out our static, and got a fan. So here we are. We get to the end of construction, and what we have is this exhaust fan, EF46, up on the roof, and you see the red arrows pointing to the speed, and that speed's at 96.2%. That was cause for alarm, cause for concern, because the chemo room in that pharmacy has a biosafety cabinet with HEPA filtration, and actually you'll see a picture of that coming up. And that was brand new, clean HEPA filter. They hadn't even opened the pharmacy yet, hadn't even started using these rooms, and notice our fan is basically up near 100%. That was raising some eyebrows. Owner wasn't happy. Why do we have no wiggle room? on this fan. And you know, from a commissioning perspective, I'm like, you know, we're kind of barely making our set point for discharge static pressure. You can see that at the bottom of the fan there. It says DSP negative 3.2. Negative 3.3 set point. So, you know, we're right about on set point there, but we're way up at the end of the fan. So we're sort of out of energy on what we can do with this fan. So go ahead to the next slide. We started to look at this and say, why are we where we are? So of course, what do? You go up to the fan, you tighten up the shifts. Let's get as much out of that motor as we possibly can. Let's get as much out of that fan. Well, we crank that thing, and you can see right where it says, where the yellow arrow is, it says total fan CFM specified 1550. We got that thing doing 2194. Okay, so we've got as much as we can get out of that thing. We've stretched that fan, that 3 horsepower motor, as much as we can. But look at below the 2194, it says at the outlets, we're doing 1597. We've got 597 CFM of leakage between the fan and the outlets in the basement. So of course, what do we do as a good commissioning engineer? Let's figure out where the heck that leakage is. Well, we tested between the fan on the roof and right at that fiberglass connection, so where the ductwork actually connected to the fiberglass, and we had, for all practical purposes, 0 leakage from the fan to the 4th floor fiberglass inlet. Then we went down to the basement and we've tested, and again, and we said, oh, that's where our leakage was all in basically for 80%, 90% of it was all in that vertical fiberglass duct. And before we go off this slide, you can notice here the balancer is showing motor speed at 95.2, set point negative 3.5. So again, everything's kind of jiving here that we're running this fan as hard as we can, and you know, we're showing a lot of leakage. So this is the before Aeroseal. So now we get into the planning, and this is where, luckily, having had some experience with Aeroseal before, I said, hey guys, I've got this product that I've heard of, I think would work. So we started putting some drawings together, and this was actually our drawing that we put together for the contractors. It actually showed the pictures on the left of the ductwork where we were planning on capping it and blanking it. It had the riser shown there, and our 3 rooms in the basement. The only thing I did for this slide was I added, there's the biosafety cabinet, you see that on the right, and above the little light in the cabinet, there's actually a HEPA filter in there. So the concern here is we're at 95, 96% fan speed with a clean HEPA filter. We know it's going to load over time, and we've got no buffer on that fan. So we started planning for that. And mind you, let me pause for a moment and go back and say, what would we normally do? Well, we would have done the first thing, which is tighten the shivs. Well, check, did that. We got as much as we could. The next thing to do would then be looking at, okay, let's go up a motor size, go to a 5 horsepower. Well, we talked about that, and that fan would not fit a 5 horsepower motor frame. So that kicked out to say, well, do we replace the motor and replace the whole fan? So you could see the snowball domino effect going, where this is getting uglier and uglier by the minute. So we said, well, our backs are getting up against the wall, and I think this Aeroseal thing might be, our solution. So this is just a blown up version, trying to give you a little description of what we were thinking. And what we originally planned was to go from the 4th floor in that machine room down to the basement where the bathroom was, and do that in like probably 2 different sealing processes. And after we worked with Bobby Seals from Aeroseal, he said, no, you know what, John, we can actually go from the roof up at the fan all the way right down to before the pharmacy, right to that bathroom. So the diagram, the drawing there shows what we were originally thinking, and capping the ductwork in certain spots. But actually on the right there, it says Aeroseal applied from roof to basement. Those are the arrows are pointing to where we kind of sealed if you looked at a riser view. And as I note there on the left, when we just did our own commissioning and did some traverses and pressure tests just from our data and our instrumentation, we were seeing over 400. So again, balancer found almost 600. We were seeing well over 400. So you can see the severity of the problem. And again, let me put this in perspective. This is a system that's only supposed to be doing about 1,500 CFM. So not that big of a system, but now we're talking about somewhere about a third of it leaking. So pretty significant. So that's the plan for Aeroseal. And this is sort of the, where we were looking out down in the basement. So on the left of that drawing, you have the fiberglass ductwork coming down, and then it transitions to the horizontal run across the basement, and you can see it changes some shape there. We got to get our aspect ratio is going to change to fit through there, and eventually it continues all the way to the right to that bathroom that is right before the exhaust duct goes into the pharmacy, which is just off the page there to the right. So we ended up sealing from the roof all the way to that bathroom in one sealing, in one seal, if you will. Go ahead. So yep, just a simple up on the roof. That's where where the machinery was cut in, and we went right into that duct right there. It was blanked off to the left, so that way the fan was all isolated. Go ahead. And this is the results. At the end of the day, what we were really trying to do is solve a problem, which was costing us energy, but really from a commissioning standpoint and a project standpoint, we had a problem to solve. And what you can see is this is what Aerosol will actually give you. They'll actually give you something that shows what they found when they tested and over time. So you can see on the graph on the right, it shows the leakage. It started with their duct pressure test where they start to apply sealant at time 0. It started at 200 CFM of leakage. It starts going up to over 300, maybe 320, and then it starts bringing it back down. So it never quite saw the full over 400 or 500 CFM of leakage because the sealing already started to take into effect. And honestly, if you look, you see 15 minutes and we're basically bottoming out. And we applied a little extra after that, and we got to 0 leakage. So we were able to seal this thing 100%, get to 0 leakage, which is a huge impact that we were able to have on the project. If you flip to the next slide, really, what were we trying to do? We were trying to get some cushion on the fan. So this is the after results. We actually were able to get back to our 3.5-inch static pressure, negative static pressure, and our fan speed is at 84.6. Now we've got some cushion on the fan. We've got time for the filters to load in the biosafety cabinet, and at the end of the day, instead of going up with a bigger motor, up with a bigger fan, increasing energy even more, we actually went the other way. We got a 17% decrease in fan energy. So, real world example of, where the project's heading one way and we were able to turn that thing 180 degrees and actually solve the problem. So here's the interesting story here out of this. The mechanical contractor, so we're just a design engineer, commissioning engineer. We were working on this and we told them about this Aerosol product and said, we want to use it. And they were pretty skeptical. And this was a contractor I'd worked with for many years, many projects before. And little beknownst to me, he really didn't believe me and thought this mystery Aerosol product was more like snake oil and smoke and mirrors. He had his buddy who was down in the basement in that bathroom drill some holes in the duct. And after a few minutes on the roof of sealing, he called over the walkie-talkie down to him and said, "Hey, how's it going down there?" And his buddy goes, "Oh, we're good. These holes are already sealed up." And everyone kind of looked at him, and he took the elevator down there because he didn't believe it that in a couple minutes it would have sealed. So he has become a believer and is using it on other projects and was sort of amazed. So that was sort of a funny little twist to this story that we were able to solve the problem. And even when he kind of phased it and kind of set us up for failure, we proved that it could handle it. So at the end of the day, we did solve our problem. So Neil, I'll turn it back to you, and I hope that gives you a little testimonial of real-world stories. And just so people do know, we've used it since on much larger systems, both supply and exhaust, and that was a healthcare project. So I will say we did have some hurdles and obstacles to overcome with our local state healthcare folks and using this product, and after scrutiny and review and MSDS sheets, etc., they were comfortable using that product in an operating occupied hospital healthcare application. So we definitely, that didn't happen overnight. It took some time and took some convincing and review, but again, we were able to do it, and we've used it in other healthcare projects as well.
John, thank you very much. I appreciate the overview of the project. So let's talk a little bit about the process itself. What Aeroseal does is it seals ducts from the inside out. If you get at the ducts from the inside, you can get 90% of the leakage or more out, and you don't have to worry about access limitations. The material itself can seal a hole up to 5/8 of an inch wide, or a seam or gap 5/8 of an inch wide, and it uses a safe, low VOC sealant that cures within 2 hours. And the most important point is paybacks are usually within 2 to 7 years for the process. The company is over almost 20 years old. Started in 1994 when the first patents were issued. In 2001, Carrier Corporation bought and held the company for 10 years. In 2010, the inventor, along with a group of private investors, bought it back. During that period of time, about 2004, the first commercial job was done with Aerosol machine. Fast forward to today, almost 10 years later, over 30 million square feet of buildings have been sealed with the Aeroseal system. Now let me give you a quick overview on the application. The first thing the contractor is going to do is connect the equipment to the duct. Then all the air handler is going to be isolated. Then we're going to block all the grills or the diffuser openings. Now there's nowhere for the air to go when you pressurize the duct but through the holes. Then we do a pre-seal test. That's going to give us our benchmark at which all our energy savings is going to be measured against. Then the technician injects a sealant. And because it's done in real time, measured in real time on a computer screen, the technician can see exactly how much leakage is left in the ductwork. When all of the leakage is taken out, a second test is done to measure the final leakage amount. That gives the before and after. And then a certificate is printed for the commissioning agent and the owner. On the next slide, you can see an example of that report. On the left-hand side is a typical certificate of completion, in this case for a school. And you can see in red is the initial leakage, in green is the final leakage, and in blue is the improvement. On the graph, the picture on the right-hand side of the screen, you can see a typical setup of the equipment in a machine room and how the technician is controlling everything through the computer. So with that, I want to turn it over, and I'm sure that you have some questions we can help answer about the process or the project that John worked on.
So thanks, Neil. The only question that we have received so far is where you might have some reps that people can get in touch with. And one of the big requests is from some of our members down in Brazil. Is there, do you have a rep in Brazil that people could get in touch with?
We can certainly follow up with you about Brazil. So we will follow up directly with you about applications in Brazil and our representation in that part of the country, in the part of the world, I should say.
And we do have a dealer locator, a service provider locator at aerosol.com, and it lists all the commercial service providers. As Neil said, we don't have anybody in Brazil right now, but we are well covered in Europe and Canada and other places like that. So,
excellent. So, any rules of thumb on cost?
That's a great question, Liz. Typically, the installed cost of an Aeroseal job is about $1 a CFM. It can be a little bit less expensive for a pure exhaust system, and it can be a little bit more expensive for a complicated supply duct. But on average, $1 a CFM is a good rule of thumb for budgeting.
And I'll throw a kind of a question and an answer that I know I've dealt with on some of our projects. Doing a lot of healthcare, we have the luxury of mostly externally insulated ductwork, but of course we do come across places that are not going to be following the healthcare or patient requirements, so we have internally lined ductwork. And I know that was one of my first questions talking to Neil and Bobby, to say, hey, I got a problem, and it's got internal insulation. So I'll throw, I threw that question to these guys and was very happy to find out that yes, they can seal internally lined ductwork. Be it does take longer, it's a slower process, so logistically it adds a little bit of complexity to it. I won't speak on the cost piece because I don't really know that side, but the short answer is yes, you can seal the internally lined ductwork.
Thanks, John. As you're thinking about projects and you're looking at potential applications, one of the things that's the easiest thing to do is just to simply take a look at the ductwork in the building and ask yourself, does this look airtight? Can I see mastic on the joints? Does it look well applied, or is the tape coming off, or it's missing? Does it look like it's missing? Is there dirty streaks on the ductwork where you can see where air has been going in and out of the ductwork? If it's externally wrapped, as John indicated, is it puffed up? I mean, we've all seen that example where the wrap is it looks like Frosty the Snowman. And as you just apply some duct leakage goggles to a job, I think what you'll find very quickly is that there's a lot of times there's very easy to identify ductwork that seems to be leaking excessively. At that point in time, it's relatively easy to come in and do a test to gauge the measurement, or simply to put together a proposal to come in and test and seal the ductwork. Liz, do we have any more questions?
We have had a couple more questions come in. Do you find the ASHRAE standard that indicates only duct above 3 inches should be tested is in conflict with what is occurring in the real world? And do you find that duct rated below 3 inches leaks just as much as a duct rated above 3 inches?
What we find, and what has been proven through independent study, is that even low pressure ductwork leaks substantially, enough to seal. At the latest ASHRAE presentation this year, at the winter meeting, the Western Center for Cooling Efficiency presented a presentation on duct leakage downstream of terminal boxes. Not only did they find that the duct leakage was excessive, but they found that there was substantial energy savings from sealing it. So we do recommend that all ducts be tested, the entire air distribution system be tested, and we find that there's a tremendous amount of energy savings by not only sealing high pressure ducts, but also medium and low pressure ducts, and that includes exhausts as well as returns.
Great.
And I'll just chime in. Actually, we had a hospital project where we were actually finding leakage and trying to mitigate leakage. So we did the medium pressure duct work, and then still were a little bit baffled and seeing leakage. So we ended up getting into testing the low pressure side and actually sealing the low pressure side. And the numbers we have, and I'm looking at my table here, the lowest leakage on one of the low pressure zones, the lowest leakage was 2.7%. The highest leakage was 38.1%. With, and those are kind of the two extremes, but if I look at most of the other numbers, they were somewhere between 7 and 10% leakage and that's from the VAV box to the outlet. So just to give you guys, and those are all actually tested and sealed with Aerosol. So because we're redoing a whole floor, and we found the leakage, kind of as we did the preliminary reading. So just to give you some reference numbers on a project we worked on.
Another question coming in, is this process suited for new construction or mostly best for existing duct systems?
We've successfully had it applied in both. Certainly it's great in existing buildings because it's a way to get to duct leakage that normally you couldn't get to any other way. But in new construction, it's a great way to make sure you're getting to the ASHRAE recommendations of 2 to 3% maximum air duct leakage.
Great. And another question, are silencers an issue?
No. Neither baffle no, perf plate silencers are a problem with Aeroseal. Because the air is not going through the perf plates, the sealant won't collect on the perforations or the insulating material in the the silencer.
And if you're doing it in existing ductwork, should it be cleaned first before you seal it?
The vast majority of time, you do not need to clean the ductwork before sealing it. If you have more than 1/8 of an inch of debris that's collected on the walls or the bottom of the ductwork, you are going to want to get it cleaned before sealed. But that's quite a bit of material before you actually need to get it cleaned.
And let's see if this one we might have asked. Do you recommend doing a system test and balance after Aeroseal application?
Absolutely. You're going to want to recommission the air handling system after sealing it. You're going to need to rebalance the flow to each one of the zones, and you're going to want to slow down the fan to generate the energy savings.
Okay, and it looks like we have one more here. For calculations, what would be considered the life of the product before it would need to be applied again, potentially?
It's a lifetime duration. The product has been independently tested at some national laboratories, and they determined that it was well over 40 years of life before the product even showed any signs of wear and tear.
Yeah, and that was a question that came up with the healthcare group that we had, and there is and Neil, you can tell me on what the number is, but an ASTM or an ANSI test that, you know, obviously the product hasn't been around 40 years, but there's a way that they test this stuff and simulate length of time, and that was enough to convince, you know, both ourselves as engineers and the owners that, yeah, this, you know, for our pharmacy, if it's still there 20 years from now, then yeah, we're comfortable that Aeroseal will still be sealing that duct for 20 years.
Exactly. Yeah, there's all sorts of requirements that we meet for application of an aerosol sealant. In fact, UL standard 1381 is the standard that applies to internal aerosolized duct sealant. So, and that makes sure that we comply with all the standards for flame development, smoke spread, mold hygiene, mold growth, as well as durability and life. Liz, do we have any more questions?
It looks like we have now answered all the comments. Oh, actually, one more just came in. 2 questions. For using this with residential, any VOC issues with homeowners? Evacuation required during installation? Any maximum hole size or size of hole that won't hold Aeroseal?
So I want to jump in real quick, only because I wasn't going to tell the story, but just so people know, before I recommended this, and I think Neil's heard this story, but he might not have, before I used Aeroseal on that actual Condell project, which was our first project, the funny story was the house that's about 30 years old that I live in personally had a lot of duct leakage, and after upgrading the fans and replacing the outdoor air compressors and condenser units, I was finally finishing kind of the upgrades, and I said to my local residential contractor, I'm like, I just got to figure out how I'm going to get, you know, air up to my daughter's room, which was always too hot, too cold, and it's a finished basement. That's the way it was when I moved in. So he was the first person that actually mentioned Aeroseal. So I could send you my own house, which we have 2 small units that we sealed both the supply and the return sides on. And so my little testimonial is, no, there was no issues with the VOCs. By the time I got home that night and the wife and the kids came home from school, other than a faint kind of powdery odor, you know, you could kind of smell that something was sprayed in the house, but, you know, we were back in the house. There was no issues. You know, we didn't have anybody home during the day when it was done, but like I said, by 3 o'clock that afternoon, the kids came home from school. We were, everyone was in the house. So that's just my own little 2 cents of I tried it at home first, and then we've been using it ever since.
That's a great story, John. Yeah, the product itself gives off negligible VOC off-gassing as it's been independently tested. It completely dries within 2 hours, and that's one of the reasons why it has such a low VOC off-gas VOC content to it. And it does a large hole, up to 5/8 of an inch in diameter, or a seam that's come apart. You can imagine a slip drive that's come disattached, so you can have a seam up to 5/8 of an inch wide that's come apart that can be sealed with the Aerosol process. Liz, anything more?
Nope, that looks like all of our questions for today. So I want to thank you guys for joining us and exhibiting this year at NCBC. We've had some great questions, and so Neil and John, we really appreciate your time and expertise. And thanks to all of you who participated today in this webinar for your time and attention. Please join us Thursday. We'll have our Industrial Network Systems webinar, another one of our NCBC exhibitors. So from all of us here at NCBC, thanks again for your attention and your questions, and have a great rest of the day.